Today, we're going to talk about solving a system of equations. Like the linear equations, a system of equation can have a unique solution, which we will say conditional solutions, or it can have all real number pairs as solutions. In that case, we will say that the entire plane R2 is the solution of the system of equation, or there are infinitely many solutions. Or the system of equation can have no solution. We will say the system of equations are inconsistent and the solution set is empty set. So what we will start working on first is two primary processes of solving a system of equation. The first one is called solving by elimination process. Your target is to look at your two equations and number them as equation number 1 and 2, like the way I will do. 3x plus y is equal to 0. I call this one equation number 1 and this one equation number 2. Then try to identify coefficients of at least one variable, doesn't matter which one. For example, in this set of equation, if I look at the coefficients of x, they're exactly the same number but opposite in sign. So what I do, I add these two equations and eliminate the variable x. See what happens. You have minus 3x minus 2y equal to 3, and then you have 3x plus y equal to 0. If I add them, I get minus y equal to 3. Hence, y is equal to minus 3. So I already know one value. What I do, I use this value in one of equation 1 or 2. Doesn't matter which one. So use y equal to negative 3, say in 2, and see what we get. 3x, y is negative 3, is equal to 0, which means 3x is equal to 3, implies x is equal to 1. So what I say the point 1 comma negative 3, x equal to 1, y equal to negative 3 is the point in the solution set. So the next problem, I have not been asked to use any particular process. So what I will do, I will just go ahead and try to understand and use the process of elimination. So let's write it as 2x minus 6y equal to 19. Call it equation number 1. Then I have minus 3x plus 9y is equal to minus 30. Equation number 2. So this one is not as good as the first one, but I can still manage. How about I decide to multiply 3 with my first equation? That makes this coefficient 6. Then I multiply 2 with this equation. It makes the coefficient negative 6. And then I add them. So write exactly what you said. 3 times equation 1 plus 2 times equation 2. And see what you get. 6x minus 18y. Don't forget to distribute the 3, which is equal to 57 as well. Distribution there. 2 times negative 3x is negative 6x. 2 times 9y is positive 18y. And 2 times negative 30 is a negative 16. So when I add them, I get them cancel. Well, they cancel as well. So this is 0 equal to negative 3. That is not possible. So this is impossible. And I go ahead and say that this system of equations are inconsistent. So there is no solution. In fact, if someone asks you for the solution set, you will say it is empty. The second process of solving a system of equation is the process of substitution. And as you look at this equation, if you look at the first one, it is already solved for y, which is good. What I do, I use this value of y in my second equation. So I say 4x minus 3 times x minus 4, as I know y is x minus 4 equal to 13. And see, this is a linear equation in terms of x, which I'm going to solve. So I get 4x minus 3x plus 12 equal to 13. And then I subtract 12 from both sides, and I get x equal to 1. And then I put this value in to find the value of y. So this is 1 minus 4, and that's negative 3. So again, The solution is the point x equal to 1, y equal to negative 3, and that is the solution set. Very nice. Finally, we're going to solve the system of equation, and this time, as you can see, I have not mentioned what process to use. So why don't we go ahead and use the method of substitution? So what I say, look at the second equation. It is x minus 2y equal to 7. Solve for x. Solve for any one of these variables. X is easier, so solve for x. Gives you x equal to 7 plus 2y when you add 2y on both sides. Then use this information in the first equation. So in place of x, you write 7 plus 2y plus 2y, that is given in the first equation, equal to negative 3. I distribute, get 21 plus 6y plus 2y equal to negative 3. Subtract 21 from both sides, and you get 8y equal to negative 24. So divide both sides by 8, and I get y equal to negative 3. So what is x? So I will go back and say x is equal to 7 plus 2 times negative 3, which is 7 minus 6, and that's 1. Hence, x equal to 1, y equal to negative 3 is the solution set. So this is a conditional equation, as was the first one and the third one, and each of them has a unique solution 1, negative 3. Now we're going to solve system of equations related word problems. So the first one is talking about an airplane travels 950 miles in 2.5 hours with the aid of tailwind. It takes 3 hours for the return trip flying against the same wind. Find the speed of the airplane. So that's one answer you want to find out. Let's call it x in still wind. And find the speed of the wind. Let's call it y. So I will say along the wind when it is going using the aid of tailwind. So along the wind, the velocity is increased. The velocity of the airplane is x plus you will get the help of the wind, so it's x plus y. With this velocity, to travel 1950 miles, you take 2.5 hours. So what does that mean? 1950 is the total distance. I'm driving at a speed of x plus y, and that is equal to 2.5. So this means if I multiply x plus y on both sides, 1950 is equal to 2.5 times x plus y. Divide both sides by 2.5, you get x plus y is equal to 1950 over 2.5. Let's find out how much is 1950 over 2.5 in our calculator. And that will be one equation of the system of equations. So 1950 divided by 2.5 is going to be 780. So I say x plus y is equal to 780. And let's go ahead and call this equation number 1. Now when you are against the wind, when the airplane is moving against the wind, then remember its speed in still air will be reduced by the wind speed, so x minus y. But it is traveling the same distance, so 1950 over x minus y is equal to 3, and I do pretty much the same work. I multiply both sides by x minus y, so I get 1950 is equal to 3 times x minus y. Then I divide both sides by 3, so I get 1950 over 3 is equal to x minus y. This calculation is simple. So 3 goes 6 times in 19, 5 times in 15, so 650 equal to x minus y. And I go ahead and call this equation number 2. So I have a system of equation. What I do, since y has the same coefficient different sign, I go ahead and add 1 and 2. That will eliminate y. So you say x plus y is equal to, in the first one, 780. X minus y in the second one is 650, and I add them, so I get 2x, y cancels, and I get 0. 8 plus 5 is 13, 1 plus 7 is 8, plus 6 is 14. So x, when I divide both sides by 2, I get 715. And see, I have answered my first question. I have answered the speed of the airplane in still wind is 715 miles per hour. I want to know y. So what I do, I use x in any one of these two equations. X is equal to 715. Let's use say in 1. And it was 715. I said 718. So let me correct that. 715 in equation 1. So you get 715 plus y is equal to 780. So subtract 750 for both sides, 15 from both sides, and you get 65 miles per hour is the speed of the wind. Answers my question for the first word problem. For our second word problem, we are talking about a school fund raising event sold a total of 207 tickets and generated a total revenue of $586.95. There are two types of tickets, adult tickets and child tickets. Each adult ticket cost $430 and each child ticket cost $2.15. How many of each type tickets were sold? So I want to know how many child tickets, let's call it X, and how many adult tickets, so let's call it Y. So the total revenue should be for each child ticket, the revenue is 215, so it will be 215X. And for each adult ticket, the revenue is 430, so it will be 430Y. And the total revenue should be equal to $586.95. Whereas the total number of tickets sold, which is X plus Y, should be equal to 207. And these are the two equations in the system. This one will be easier if I use the process of substitution. So solve the second one for X. X is equal to 207 minus Y. Use it in the first one, so you get 2.15 times 207 minus Y plus 4.30Y is equal to 586.95. So I'm multiplying 2.15 with 207. Let's do it in calculator. 2.15 times 207 should give me 445.05 minus 2.15y plus 4.30y is equal to 586.95. So if I subtract 445.05 from both sides, because I will essentially solve it for y, so I want the numbers to be on the other side, I will get, now these two numbers together will give you 2.15y, 4.30 minus 2.15. Should be equal to 5 minus 5 is 0, 9 minus 0 is 9, 6 minus 5 is 1, 8 minus 4 is 4, 5 minus 4 is 1. So 141.90. Then I divide both sides by 2.15. It will solve it for the value of y. So let's do it again in our calculator. So 141.9 divided by 2.5. It's around 56.76. So it should be a whole number, and because I'm not getting a whole number, I would like to check my work one more time. So let's see whether I have written down everything right. So child ticket should be 2.15 times x plus 4.30 times y is 586.95. Then I have x plus y is 207, so x is 207 minus y. 2.15 times 207. Let's do that calculation one more time. 7 times 2.15 is 445.05 minus 2.15y plus 4.30y. So that's 2.15y, and I will do the subtraction in the calculator one more time. So 586.95 minus answer is 141.9, and it seems like we did it right. So we divide both sides by 2.15, and my answer is going to be divide by 2.15. Oh, it is a whole number, so it is 66. So I get that is equal to 66. And remember, what was y? Y was the number of adult tickets. So I will now know the number of adult tickets sold is 68. So then I'm going to find out what is the number of x. Or how do I do that? I just put this 66 back in this equation, which will give me x equal to 207 minus 66, and that is 141. And that answers the question for the number of tickets that we wanted to know. All right, so we'll go to our next page and answer the last question. For the 2009 Major League Baseball and National Football League seasons, based on average ticket prices, 3 baseball tickets and 2 football tickets would have cost $230, while 2 baseball tickets and 1 football ticket would have cost $128. What are the average ticket prices for the tickets of these 2 sports? So I will say these are the 2 information I want to know. Football tickets, I will say the average price for the football ticket is say X, and the other one is the baseball ticket. So I will go ahead and say that the baseball ticket, the average price is the other variable Y. Then read the problem one more time. 3 baseball tickets, so 3Y, plus 2 football tickets, so 2X, should be equal to around $230. Whereas 2 baseball tickets and 1 football ticket should be around $128. And these are my 2 equations and the system of equation. I want to know X and Y. So what I do, I keep the first equation and I subtract 2 times the second equation. Why I do it? So if you multiply 1 with the first one, 2 with the second one, see the coefficient of y is not exciting because you will get 3y plus 2x equal to 230 on the first. I just multiplied 1. But the second one, you get 4y, you are subtracting. You get 2x, you are subtracting. And you get negative 256. So the x is getting eliminated. So I get minus y equal to minus 26. So y is 26. So at once, I have found out what is the baseball ticket's average price. It's around $26. I want to know the average price of the football ticket. So use y equal to 26 in any one of these 2 equations given. So say for example, use it in number 2 and see what happens. 2 times 26 is y plus x is 128. Solve for x. So you get 52 plus x equal to 128. Subtract 52 from both sides and you get x is equal to 128 minus 52. So that's 76. So the average football ticket price is now found out and it is around $76. And that answers this question. So we're going to stop here for this lecture note. Start working on your homework problems in TOPAD as soon as you can. If you have any question, do not hesitate to write me back and I will get back to you as soon as I can.